All right, welcome to week 3 of Python programming. We're going to be working on variables and statements now. And I'm going to say this now, but it'll apply to pretty much every single chapter and concept that we cover. This is really important for you to understand. Each week in this class builds on the previous week. And so if you don't understand a concept, it's going to be really hard to move on because the next week is going to assume that you know what you're doing as far as these concepts. So make sure you're cluing in. Make sure you are stopping the screencast. If there's anything I say that you don't understand, stop it, Google it, reach out, shoot me an email. But make sure you're interacting well with this content. All right, so let's dig in. Variables and statements. Variables. I like to think about variables like buckets, or like maybe a trash can, like a waste bin that you might have at your house. It is just a container. It's a container that can contain anything, and what is in that container might change. At the root of that word variable is vary, meaning changing. And so this is a container that what it contains will change over time. And so if you variables have names, think about if you had 10 different trash cans in your living room. Hopefully you didn't have, we'll say your garage, make it a little bit cleaner. 10 different trash cans in your garage, and you label the trash can so that maybe somebody else that's in your garage, you can talk to them and say, so you dump some sort of item into the trash can. We'll say it's a number 5 into trash can 1, number 10 into trash can 2, and number 15 into trash can 3. If you were to say to your friend, hey, what's in trash can 3? He's going to look in the trash can, dump it out, and say, that was the number 15. And so you can refer to what is in the trash can by its name. And that's basically how variables work. They're just a container that can contain values of different types, and that whatever those values are can change over time. So specifically, a variable is a name, is the name that refers to the value. And so let's learn a new concept. This is called a statement. So a statement has any statement, but we're talking about the assignment statement. It has 3 parts. So the part of this is the name of the variable on the left, the equals operator, and an expression on the right. So we're going to talk about expressions a little bit later, but here's your 3 parts. And so essentially what you're thinking about is you're saying, okay, take this value over here, and this says dump it into this variable name here. And then we can just refer to the variable name later. It's like a shortcut. And so you can see some examples, things like that. I'm going to use Visual Studio Code today to show you some things. We've talked about Colab in the first couple of weeks, but some of y'all might be using Visual Studio Code instead of Colab, and also I just want you to see what it looks like to use a quote unquote real IDE, integrated development environment. And so let's going to use that. So I'll create a new file, and I'm just going to put comments here. This is a Python program to demonstrate variables and statements. And I'll save that. And it's going to ask me for a file, and I'll just say variables and statements.py. And I'll save that. Okay. Notice as soon as I saved that as a py file, it turned this color. I don't know if you noticed that. And that's because I have some extensions already installed for Python. This right here, Python language support. And so because I have that extension installed, it says, oh, this is a .py file. I know what that is. That's a Python program. I know that any line that starts with the Pound sign. Oh, that's a comment. So I'm going to make it this color. So that's what that was about. So let's learn about statements here. I said that the first thing, what comes on the left, is the name of a variable, and so we're just gonna mess around with maybe a real world example of an amount of money, and I'm going to say money in wallet equals $10. Okay. What I'm saying is that take this value 10 and deposit it, insert it into this variable, money in wallet. Looking at colors here, it's giving you some important things here. Hovering over things is important in an IDE like this. So if I hover over this, it tells me, hey, this is a variable. And this is the name of the variable. You can see this is a literal value, so it colors it differently than that. And so if I just say print money in wallet, then I save it and I'll run it. And so down here in the terminal, this is the output from that. So I printed the value 10. Why was it 10? Because I assigned this value into that variable. Now, if I assigned another value into it, then you see a different number gets printed out. Reassignment is very, very important. And so if I started with 15, notice a couple things just as I'm working with this IDE, because I'm both trying to teach you programming and I'm trying to teach you working with different language environments. This is pretty nice because I don't have to keep typing. It recognizes, hey, you got a variable named this. Looks like maybe you're trying to type that, and so using tab is really, really helpful here. So if I start typing MON and I say, oh, that's the right one, and I hit tab, it fills in the rest. And then notice as I'm typing, I have an incomplete statement here. This is not syntactically correct. The syntax, the structure of it is not correct at this point in time. And it's yelling at you saying, hey, I'm expecting an expression to the right of equals. That's the way you got to do it. There's no other way. And so as you're typing, you're probably thinking, well, just give me a second. Give me a second, Visual Studio Code. I'm typing. I'll finish this statement. But if you'll get used to seeing this and you'll get used to noticing when things are awry. And so it has made everything red saying, hey, there's a problem with this code. And as soon as I finish that, it says, okay, I'm fine now. And now if I print money in wallet and save it, this 15 right here is a result of this print statement on line 4. And then I have the exact same print statement, but I have reassigned the value of this variable. And now I print it again, and it's got this number. So you can assign a variable this is really demonstrating the fact that it varies, it changes. As you're writing code, what gets stored in a particular bucket is going to change. That's part of the value of it. So you've got basic statement right there. This is let's say we're just saying, well, I got $15 in the wallet, but I also got some money in the bank. I can create another in bank. Notice I got a yellow squiggly line and everything is yellow. It's not red. This is just telling me, hey, there might be a problem here. What's the problem? Well, money in bank is not defined. Oh, so you're trying to use a variable that hasn't been defined yet. Okay, well, what happens if I finish this? Okay, then it's not a problem anymore. Now I've got a variable that has been defined and it has money. And so I can print both of those values. Now I've got options. See, I can just go down and hit enter and save that and run it. Okay, so now I've got this print value here is based on line number 5, and this one is based on line number 6. And let's say I wanted to calculate the total amount of money that I have. Total money. What I would certainly not want to do is to do this. Bad, 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 bad. You never want to repeat literal numbers like this in programming, because you might look at this and go, well, I mean, if that money in wallet changes, I mean, I'll just change this to 20. And I mean, I could always I'll just go down here and change this. That's fine. I mean, how hard is that? Well, not hard in this example, but let's say your code has several thousand lines of code. Your program has several thousand lines. Not unrealistic. In fact, if you're working at a company, you might be doing software development. You might be working with a code base that has millions of lines of code. Where are all the places where this money in wallet variable is found? Who knows? And it's just bad. You're kind of breaking the point of using a programming language. And so instead of repeating myself, I'm just going to say I'm going to talk about this sort of in algebraic terms, where you have x represents a number, and I'm just going to refer to it here. I'm going to say that my total money is equal to the money in the wallet plus the money in the bank. And now this, to a human, begins, you could actually read this. This is syntactically correct Python language, but it also reads pretty well to a human. Yeah, my total money is equal to the money that's in my wallet plus the money that's in the bank. Yeah, that makes sense. And so I could then print total money. Let's see how that works. So 220 plus 100 equals 120. And now if you come here and say, well, you know what? I bought something. Now for $5, I've only got $15 in my wallet now, and run it. And notice this changed as well as this changed. I mean, if you've worked with Excel, this is, kind of the same concept of using a formula in a cell. The values that are going to be in a variable could change, and then you can take those values, refer to them by a name, and do calculations with them. This is the basics of what it means to use variables in the language. Going back to our textbook, just want to let's talk about variable names. So here's the thing: you're the programmer. You get to name your variables whatever you want. You could name them as long as you want. You could name them as short as you want. Going forward, it's going to be very, very important that you use what I call meaningful variable names. So what do I mean by a meaningful variable name? Well, let's use this example, and let's make it not meaningful. Okay? I'll show you what I mean by that. So instead of that, we're going to say, see what I'm doing here? Just replacing these. Okay. This right here will accomplish the exact same thing as this right here. So you're going to see the same thing twice. There's 1,500, 115, 1,500, 115. So what's the difference between these two things? Well, the computer doesn't really care what you name a variable. It can be as nonsensical as you want, as long as you follow the rules. There are rules in here, like you can't use special characters and things like that. So you have to pay attention to the rules. But as long as you follow the rules, computer doesn't care. Human, however, human cares. If you were just to look at this code right here and look at that, let's say you're working on a team, and the team member comes in, and you're off that day. You're vacationing in Tahiti, and the customer calls and says, "Hey, there's a problem in the code. Your calculations aren't right. My bank balance isn't right." And so one of your teammates has to go in there in this code you wrote, and they open it up and they see this, and they're going to go, "What in the world is happening in this code? This makes no sense," right? Because This is not meaningful to a human. Works for the computer, not meaningful to the human. Now, if the code looked like this, they could get in there and go, oh, okay, I see what he's doing. So make sure your variables are meaningful. You'll notice a couple conventions here. I used sort of what is typical Python variable naming convention, meaning most people in the programming community are going to do it in the same way. And that is you're going to separate words with an underscore. So an underscore is a valid character for a variable. Could I do it like this? Yes, but look, just reading it, just scanning it, it's a whole lot easier to read this than it is this, isn't it? And so using underscores helps readability. Um, you know, variable length is less important than a variable name that means something, because you saw, most people, if you're working in an environment, you're going to have a tool like this where I don't have to type the whole thing. I can just hit tab and it's good. So whether if I'm typing the first couple lines, whether this variable name is, what is that? 5, 6, 8, like 12, 13 characters, whether it's 13 characters or 30 characters, the time it takes me to enter that variable name in actually doesn't change because I'm just hitting tab here. But there's sort of like a reasonability test here. You make it too short, it's not really meaningful. Make it too long, then it's kind of more difficult to read. So there are some exceptions to that, which we'll go in later. There are variables that we would use just with the letter I. That means something in particular in most programming languages. We'll cover that when we talk about repetition. But in general, make your variables read to a human and be descriptive of what is actually in that variable. Very important. Don't mix conventions. So like some languages, instead of this, like Java, for example, the convention would be to do money in wallet, like that, where there's no underscores. The first is undercase, lowercase, and then uppercase for the other words in a sentence. That's sort of like the Java convention. It's like, okay, if you use that convention, Python, you might get some strange looks if you, are putting this code out there in the world or working in a team. But technically, it works. Just stick with that naming convention. So you'll see me use this convention throughout the semester. Okay, let's see. So let's talk about expressions. An expression it could be an individual value, it could be a variable name, or it could be a combination of multiple things. And so let's just talk real quick about the different operators that we have that we've talked about. So you have the addition operator, that's the plus sign. You have the multiplication is the asterisk, subtraction is the dash, and then division is the /. So those are different operators, and so these characters are now shorthand to the language that tells them to take some sort of action, operate in some way on different things. And so the way expressions with multiple pieces are described is you have an operand and an operator and an operand. Okay. So the operator goes in the middle, and these are some operators. We also did the assignment. Just learned that one. So these are different operators, and so it takes something on the left and something on the right. Now, in some of these, it doesn't matter in which order the operands are, right? So 4 plus 3 is the same as 3 plus 4, right? Doesn't matter. However, 4 divided by 3 is not the same as 3 divided by 4, right? So kind of use common sense here in terms of when they make a difference. But both of these are operands. So the thing that is being operated on is called the operand. And in the assignment statement, the left operand is the name of a variable, and the right operand is the value to be assigned to the variable, and the assignment operator does that. Okay, like who really cares what these things are called? But it's important to get your basics here. Okay, let's go back to our code. Let's build an example here where we're using multiple different variables here. So let's say we're talking about a person and we want to know what their name is. Okay. So here's an assignment statement. Here's an operand on the right, which is the value, and it's going to be assigned into a variable named person's name on the left operand. Notice a couple things. One, this is sort of like a brownish orange thing, and that's because this is a string. You'll see that it's different than this over here, which is an integer and a float. So these are like numeric values, and this is a string value. Okay. And let's say the dog's name is Fido. Okay. So I have two variables now, and now I can build a sentence. And we learned a little bit about this last week with the concatenation operator. Let's add another one in there. Okay. Let's use the concatenation operator. And so this concatenates or squishes together different strings. And so person's name. Okay. So I'm going to squish together this, whatever string is in this variable. I'm going to squish it together with this string, and then also squish it together with whatever's in this variable. Again, noticing I'm working in an IDE, and so some other things that it's helping me with is if I click on this variable, notice it highlighted over here. It's telling you, hey, this is where that variable was defined. And so if you want to know what is in that variable, go up to line 13. Also notice it says variable, dog's name, it's a literal, and what is currently held in there is Fido. All right. So if I print that, that one, and run it. Okay, this is way down here at the bottom. That's what got printed out, because that is what this variable now contains. Now, because none of this was entered in from an external source, Visual Studio Code knows exactly what that string is going to look like, and it's telling you Susie Campbell has a dog named Fido. So that's pretty cool. I can also do something like this: print person and dog, and I'll concatenate and has that. So now I'm concatenating two variables. This variable is a concatenation of this variable and this variable. So you can kind of see how they all kind of come together. I click on this variable and it highlights this. It's used here. It's used here. It's defined here. And that's why the highlighting is different. This one, used here, defined here. Okay, we got a problem. What we got? We have a traceback. What's going on? So this is not right. So we got down to Susie Campbell has a dog named Fido, and then we got an error. Okay, now we get to learn about errors. Most recent call last. So I'm in this file, and it says in line 18, there was a problem. And I was trying to print. This is the line of code that was trying to be executed, and it says I've got a type error. I can only concatenate string, not int, to a string. Okay, I know what's going on. I'm trying to walk you through what the way you might look at this. You might say, okay, what? Man, I can only concatenate a string to a string. What does that even mean? And what's the problem here? Well, let me go look at line 18. Let's see what's happening. I'm trying to concatenate two things. So here's an operator. I have an operand over here, and I have an operand over here. The rules of concatenation say that the operands on either side of a concatenation operator must both be strings, because you can't concatenate an integer, which is a whole number. I can't concatenate a whole number with a string. And so I'm looking at this and going, okay, well, person and dog, what is that? Well, if I hover over it and look at it, I go, okay, that's a string. And total money, oh, you know what? The value here, that doesn't have quotes around it. That's not a string. That's an int. And so it's telling me that this expression right here, here's an operator, and here's an operand, and here's an operand. This is my problem. And if you remember from last week, I have to tell Python to treat this like a string. So I call this a string function. Notice we've got a new color here. So function calls are going to be a different color. Learn about more of those next week. Notice I've got different colors of parentheses, because this closing one matches this opening one, and this closing one matches this opening one. Just really trying to help you see the value of using an IDE. Okay, so let's see if I fix the problem. There we go. Susie Campbell has a dog named Fido and has 115. 115 what? Well, maybe I should put a $sign in there. Okay, yeah, that makes more sense. Okay, so you see how variables and expressions work together. You can combine, move, add, just use any combination of operators with different operands, and those operands can be variables that are themselves defined by other places, so that it all kind of works together. Let's see. We talked about another. I'll come back to that in a second. We talked about this guy right here. And this was the repetition. Okay, so here's operators that we now know how to use. We can use the addition. We can use multiplication, subtraction, division, assignment, concatenation, or repetition. Now, what you'll notice here is that the actual character, they're called overloaded operators. It's the fancy term for it, but it means that the same thing can do multiple operations based on its context. And so if you just look at variable 1 times variable 2, if you were to just look at this expression in isolation, and if I asked you which operator is that, you're going to say it's the asterisk, and I would say, no, that's the character. What operator? What is it actually doing? You're going to say, well, it could be doing repetition, or it could be doing multiplication. How do I know? Well, the only way you know what it's actually doing is the type of data that is held in each one of these variables. So the operator will change its operation. The character is going to change its operation based on the operands. And so in this case, if we're using the asterisk as the character, if both of these are numeric, meaning they're integers or floats, then it's going to choose to do multiplication. If one of them is a string and the other is an integer, it's going to choose repetition. Let's kind of look at this for a second in our example. I'm just going to leave all this code here. We can, I'm just trying to show you kind of how all this works. So let's just do this. Okay. I've got errors, right? Or warnings anyway, that, hey, it's not defined. It's okay. We'll get there. So I'm just going to print the result of that. So let's now define variable 1 and variable 2. And let's make them numbers. It's 15, some big number. Okay. So I have this as an operand here, and I have this as an operand here. And so this operator now is going to choose multiplication because of the type of data that's being stored here. And let's just run it. So here we are. That's the result of that calculation. Okay. Now let's make this a 3, and let's make this a string. Well, actually, that's a good example. I'm going to leave it like that. Actually, you know what? Let me show you like this. Okay. Same exact values to the human anyway. You're like, well, yeah, 15, 47, 26. Apparently that's 70,890. So when I run this code, what is that? What is this? It's not the same thing. That is a humongous number. Who knows what that number is? What is going on? Well, this is not an integer anymore. It is now a string. Notice how it's got the quotes around it. And so a string is just just because there's numbers in there doesn't mean it's actually a number. It just means that, hey, this is a sequence of characters. So those characters could be anything. And so now we have an integer over here, and we have a string over here. And so now this operator is no longer the multiplication operator. It is now the repetition operator. And so notice what's happening. The characters 4726 are repeating 15 times. 4726, 4726, 4726, all the way down 15 times. Okay, that is the repetition operator. And it's an example of an overloaded operator, just like the plus sign is a overloaded operator, because it could be concatenation if both operands are strings, or it could be addition if both operands are numeric, whether that's an integer or whether it is a float. Okay. Let's go down. I'm going to come back to the import statement here in just a second. Learn about the print function, arguments. Let's learn about that. Okay, this right here, key concept. Very, very key concept. 3 kinds of errors that can occur in a program. You saw one of those kinds of errors when I was before I did this bit right here, before I did this, you saw an error. Remember the traceback? That error was an example of a runtime error. Okay. So a runtime error. Well, let me back up. Syntax error, we talked about this last week, means you've broken the rules of the language. If there's an equal sign, there has to be an operator on the right side, and an operand on the right side that represents a value, and there has to be a variable name, a valid variable name on the left. Like, that's just the rules. And so if you break that, your code is not going to run, and it's going to give you a syntax error. So syntax errors are generally, in an IDE like this, a syntax error is generally told to you before you even run the like you could see as I was typing, it's telling me syntax errors. Like if I say variable 1, okay, syntax error. You can't name a variable like that. Okay. Problem, red, blinking lights, syntax error. This code is not going to run if I hit save. It's not. You see nothing ran. So here's a good example, or a good way to tell the difference. Over here, you can see some of the lines of code actually ran, and then all of a sudden it stopped. That's because this is a runtime error. Syntax errors, you see nothing ran, because it's like basically Python's saying, hey, I looked at your code, you got problems. I'm not even going to start. And so that's an example of a syntax error. So this runtime error means something happened during the time the program was running. That's why it's called a runtime error. It can start running, but something is going to go wrong at some point, and it's going to display an error message, and it's going to stop. You'll see this also called an exception. And so this was a runtime error up here when I before I had done this this string casting, because it was run along just fine, boop, 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 and it didn't really understand that was going to be a problem until it tried to execute the code, and then it's like, oh, wait a minute. Another example of classic example of runtime errors are going to be like division by zero errors. You got two variables, you're dividing one by the other, and the denominator happens to be a zero. Well, your code doesn't know that until it goes to run it. And so that's called a runtime error. Third kind of error is a semantic error. Semantic means meaning. That's where that word comes from. And so semantic errors are much harder, but also very, very important. I'll give you an example. Let's say I'm trying to do tax calculations, okay, sales tax, and so I'm going to say my subtotal is $100, and my tax rate equals 0.0675. That's the tax rate, in a lot of counties in North Carolina, and so I want to know my grand total. Okay. Perfectly valid code. No syntax errors here. Okay. Let's look. We're just going to add this down to the bottom here. I need to print it out. Okay. So we're down here. No runtime errors. I didn't get a trace back. All's well. Got no errors, right? Wrong. There is a very significant error here, and it is a semantic error. That means it's not doing what was intended. This calculation is not how you calculate a grand total. If you were a business and you had a program like this that calculated the customer's grand total in this fashion, you are in big trouble because you're going to lose a lot of money, because this is not how you calculate it. The way you would calculate this is the subtotal plus the subtotal times the tax rate. That's how you calculate a grand total. Look at the differences here: 106, 0.0675 or 106.75. If you're a business, you've just lost $6.70. This is bad business, right? So that's what a semantic error is, that you've got a problem in your code. This can only be discovered and corrected by a human looking at the code going, is that how you calculate the grand total? No other way to do it. So those are the three kinds of errors that you will find. Syntax errors, very, very helpful to use an IDE because it will not even let you execute. Runtime errors, you're going to see it in the output of your code, and you're going to have to pay attention to what line of code it is, and go back and use your debugging skills that you're going to develop this whole semester to figure out what the error is. Semantic error is you're going to have to look at the output of your code and say, does this make sense? Does this make sense to the human based on the requirements that are being asked of me? Okay. Last thing is they cover it here. We're not actually using it in this module, so that's why I'm not really spending a lot of time here, but you have the import statement. And so import allows you basically a collection of other variables and functions and things like that are outside of the base Python language. And so classic example of that is being able to access a value, the pi value by name, without having to actually remember, hey, this is what this is. Okay, let's talk about what the assignment is going to look like for this particular week. Got that over here. Okay, so we're gonna put these concepts to use. We're going to practice variable assignment. We're going to practice some string operations. We're going to work on how you structure output so that it's nice and looks good to a human. And so we got the requirements up here. So you got to have 4 variables. The first one is going to be a name. The second one is going to be a goal, like building a mobile app. The idea is we're creating a professional bio. And then we're going to have a variable that represents a birth year and the current year. We're going to need to calculate a fifth variable, which is the age. And you do that by subtracting the years. Again, this is one where you're going to have to think about it from a semantic perspective. Okay, if I'm going to calculate age, is it birth year minus current year, or is it current year minus birth year? I'll leave you to figure out which way it should go. We're going to do some string repetition. We're going to use the repetition or multiplier operator to create a border of 25 characters. And you can use like the equal sign. You can use any of these signs. And we're going to display this in multiple lines. Okay. Here's your 3 commits. First thing, and as we go along, each assignment, I'm going to be giving you less and less direct, like copy and pastable kind of examples here, because you need to learn how to actually do this. So step 1, part 1, is we need to create our structure. Let me remind you what that looks like. Let me create a new file here. I think it's that one. Yep. Week 3 example.py. Okay. So here's how you're always going to start. Import statements. You're going to be able to do this in your sleep. Function definitions. Program logic. Okay. We're beginning. We're not ready for our first commit yet. So include your headers. So in the logic section, we're going to think about let's think about a plan. How am I going to accomplish the requirements where I have an output that looks like this? My name is Jordan. I'm 22 years old. My goal is to become a software developer. How am I going to, what's the plan? Well, again, we're starting, so I'm kind of giving you an idea what the plan might be. Here's an example. Assign values to a name, a goal, a birth year, and a current year. Okay. You doing this in comments. Assign values to variables. What are the variables again? Okay, name, goal, birth year, current year. Okay, so I'm going to assign values to those variables. Next, okay, I need to calculate the age. My age. Next, okay, I'm going to print a top order. Then I'm going to print my bio sentence. And then I'm going to print bottom order. Okay. Now, does this plan look like it's going to accomplish these requirements and give me this output? Yeah, that's the idea, right? And so this right here is your first commit. Okay, so part 1, commit 1, structure and pseudocode. This is what you need to save to GitHub. Let me show you again how this works in Visual Studio Code rather than Colab. This is my source control menu, essentially, in Visual Studio Code. So the first thing I need to do is I need to initialize, make this a Git repository. Okay, so now it's noticing, it's picking up some files and some things that have changed. I'm going to close this out. I'm not going to worry about this one. You'll kind of see how this works. So I'm ready. So I'm ready to commit this. So I'm going to hit the plus because I'm going to stage this change. This says this one's ready because you can stage multiple files at a time. So my first commit message is structure and pseudocode. I'm going to commit it. Now notice I'm working on my local computer here. So in order to publish this to GitHub, I've also got to, let's see, push to repository, no remotes. Where do I go to? It's up here, repositories, publish to GitHub. Thank you. I've already connected Visual Studio Code with my GitHub repository. Hopefully you have as well. And so I'm going to publish to my public repository. You see down here, things are going successfully published to the GitHub, and I'm going to open that. And so there is my yours is going to say week 2, right? Let's see right here. Oops, sorry. New repository down here. Let me go back and show you how this is going to actually work, because I want to make sure you can follow along with what I'm doing here. One moment. Again, I told you I don't plan these things out to be exact. So I'm going to go here. I'm going to open a new folder. So if I'm working on my local machine, I'm going to say this is week 3. I'm going to create this as week 3. Well, let's see. No, you see what? What you need to do is you're gonna let me back up. You're gonna have a folder that says think Python assignments. This is your whole repository, and you've got one from week 1 that you did. You've got one from week 2 that you did, and now we're going to be working in week 3 like this. I'm going to actually just take this. I can do this here. That's okay. And I'm going to open this folder. Yep. So this is what yours looks like. You're going to be working with each week as a separate folder. This whole thing is a repository. I'm going to initialize this as a repository. And I need to add a file here in week 3. What did I ask for it to be named? Does it matter? Does not matter. So I'm going to make it be something meaningful. And I'm going to say it is a biogenerator.py. Okay. So this is what this is going to look like. Is you're going to have a folder on your computer that contains all of your work for the whole class. And here is my first commit on this particular file. I'm going to stage it. I'm going to stage the change. I'm ready. I'm going to commit it. This is my first structure and sudo. You know what? I always forget how to. Is that how you spell sudo? SEU. I always forget that. SEU. This. Okay. And I'm going to commit it. And I'm going to publish this whole repository to GitHub. I'm going to publish it. It already exists. Oh, yeah, that's right. Yeah, it's nice. Let me go through and delete that old one. I'm going to use this. Let's see. How do I delete a repository? It is. Where's the settings for the repository? It's in actions. No. Here. I'm missing my settings for this. Oh, because I'm not signed in. Signed in. Because this is a public repository, so anybody can see it. Here we go. Settings. Nope. Where is it? Settings. This settings. And I'm going to go down here to the danger zone, and I'm going to delete it. Yes. It's like, are you sure? It doesn't let me copy and paste. It's like, no, I want you to type it. Okay. So now I come here. I'm going to come here. I'm going to publish this to GitHub as a public repository. And there it is. Let me open this repository in GitHub. So notice I've only got week 3 here because I didn't stage anything in week 1 or 2. And I'm going to click here, and there's my file, and that's what it looks like. Okay. Sorry about that little back and forth, but this is the sort of thing you guys, you got some feedback in previous weeks, probably related to the tools themselves, and it's just one of those things. Working with the tools is just as important as actually knowing how to program. And in my experience, maybe because I'm not a superhuman, but the tools sometimes are way more frustrating than actually the code itself. So anyway, you got a little bit of taste of what that can look like. Okay, so I have done my first commit. So I've done that. All right. Now, implementation part 2 is I'm going to define all the variables and I'm going to perform the age calculation. I want to print the top border, and I want to start working on the bio to ensure the spacing is correct. And I need to commit before I complete it. So what does that look like? Define all the variables. Well, I'm going to start. I've created my plan with comments. Now I get to start actually, working the plan. So here, now I get to actually start writing some code. So name equals John Smith. It can be whatever. Goal equals I want to rule the world. Birth year. This person was born in 1971. Current year, doing this in 2026. Okay. So there it is. And now I have implemented this comment. So this comment was my plan, and I have implemented it. That's good. I'm going to save this. And I'm going to run it just to make sure I don't have any errors. Okay, nothing outputs, but that's cool. Got no errors. All right, now the next part of my plan is to calculate the age. All right, so I'm going to say age equals, and I want you to think about this for a second. What should those variables, what should this expression look like? Is it birth year minus current year, or is it current year minus birth year? My age is current year minus birth year. Okay. Better run that. Okay. No errors. This is good. All right. I'm going to print my top border. I'm going to use an equal sign. And the requirement said to print a top border line using string multiplication. It said use the multiplier operator to create a border of exactly 25 characters, like the equal sign. I'm going to use the equal sign. So that would look like this. Print equal sign times 25. Okay, and I'm going to run it. Okay, that's what that is. And now I'm going to print. It said to print part of the bio sentence. Okay, here's what it should look like. My name is Jordan. I'm 22 years old. Okay, I can just print that. So print my name is, well, it's not Jordan. It's this. So now this is where I'm using concatenation. My name is name. And I am age years old. Okay. I'm going to run this. Okay. Hopefully you all were sitting here thinking to yourself, that's going to be a runtime error. That's going to be a runtime error. I know it is. I know it is. That's because this guy, right? Remember our familiar thing here? We've come across this before. I cannot concatenate a string with an int. Here's my int. So I'm going to call cast that to a string. Okay. And I'm going to run it. Okay. Here's my first. My name is John Smith, and I am 55 years old. You put a period there. That. Does that look right? Yeah, that looks right. Okay, so I'm at the midpoint now. And so notice I've got this M. That means this file was modified. See the modified right there? So when I'm ready to do my commit, I'm going to stage it. And I'm going to commit with my message being midpoint. And I am going to push one commit to, this is pushing it to GitHub. Back over here. If I refresh, there's my new code. If I look at my history, this is my first commit. It looked like this. This is my second commit. It now looks like this, right? So then I'm going to go part 3, final polish. I'm going to finish, complete the rest of the bio in the bottom border, ensure that each border is strictly on its own line and matches the length of the other. I have given you the code for part 1 and part 2. I'm going to let you finish part 3 on your own and do that final commit. Real quick, I do want to show you what this looks like in Colab. I know a lot of y'all are new to this. This is, really just the second assignment we're doing in Colab. So real quick, I want to show you what this would look like. Same thing. I'm going to name this, what would I name this thing over here? Bio generator. Bio generator. And I'm not going to retype all this stuff. I'm just going to copy and paste. But you can kind of imagine what this would look like if I were doing that. Okay, so here is my structure in pseudocode, right? So let's say file, save a copy in GitHub. Yep. Gotta sign in. Okay. Now I can save it. What? What's the problem? There it is. Okay. So my repository here is going to be think Python assignments. This is the one I was working on. Now remember, this is where some of y'all got tripped up. You've got to use folders in this file path. 3/bio generator.ipymb. Commit message is structure and pseudocode. Okay. So I'm using this as a folder, and this is my file name. Now it's not .py, it's this ipymb, which is the collab notebook. Hit OK. Okay, so notice I've got the same folder. I pushed this guy from Colab and I pushed this guy from Visual Studio Code because they're both integrated with GitHub. And so this is what my file looks like here based on this commit. I'll go back here. Again, I'm not going to write it all out from scratch. Here I'm implementing that comment. Here's where I'm implementing that comment. Here's where I'm implementing that comment. And here's where I'm beginning to implement this comment. Okay. And so I can run this. Okay, it's the beginning. That's good. That's good. All right, so now I'm going to file, save a copy in GitHub. Now remember, you have to add this each time. Week 3. This bio generator. Commit message is midpoint. I'm going to hit OK. Okay, same file. Now I have new contents. If I go to the history, I've got 2 commits now. Okay, so same thing. If you're using Colab, now finish this line right here and finish this and do the final commit that says you're done. So I wanted to show you what it looks like to work in both environments. because I know some of you are using one, some of you are using the other. And regardless, even if you're using Colab, I want you to see what it looks like to actually work in Visual Studio Code. That is a very kind of industry standard IDE. So, okay, that was long. It's probably a little bit longer than these are normally going to be, but I know we're still building up brick by brick here. So I don't want to assume that you know anything going forward. So that is all that we need for week 3. If you have any questions, use the Q&A forum, shoot me an email, and good luck.